Welcome back to the AI Recruiter Voice Assistant series. So far in this series, we have covered a lot of ground. We started with the overall architecture and design choices, including why we picked Pydantic AI for agent orchestration. Then we went deeper into the resume agent and the interview agent, exploring their prompts, tone, output, and structure. After that, we built the evaluation flow, wiring and error handling, business rules, and schema validation. And in the last video, we took things further. We tested all our agents, simulated a full candidate interview using LLMs, and tied it all together with APScheduler and Calendly webhooks for end-to-end automation. That's been the foundation. And now we are moving into the most exciting part of this project, bringing the recruiter agent to life with real-time voice integration using VAPI. In this video, I'll walk through how we implemented voice, prepared the system for production deployment, deploy the agent and render, and even looked at real-world cost calculations to make sure it's practical. Before we dive into the voice integration, let's take a step back and look at the big picture of our Recruiter AI voice assistant architecture. Here is how it looks at a high level. The candidate books an interview slot through Calendly. That booking flows into our scheduler inside the Recruiter AI voice assistant. When the interview time hits, our agent initiates a phone call to the candidate via VAPI. From there, the system coordinates and conducts an interview using three core agents: the resume agent, the interview agent, and the evaluation agent, all orchestrated with Pydantic AI. We store and manage data in Supabase. That's the end-to-end loop: scheduling, automation, intelligent interviewing, and storing results, all working together. If you have not seen the earlier videos in the series, I highly recommend going back and watching them first. We covered how each piece, the agents, prompts, schedulers, and automation fits into this architecture. And of course, if you're enjoying this series, make sure to subscribe to the channel and hit the bell so you don't miss the next episodes. And finally, if you're a business owner and you see something here that sparks an idea, whether it's building a recruiter assistant like this or something completely custom for your business, we can help. Schedule a free consultation call with us. Link is in the description. Right. With that context, let's move into the exciting part: real-time voice integration with VAPI. This is how the actual phone call happens. This is where VAPI comes in, our voice assistant platform that powers the real-time, human-like conversation with the candidate. Let's start with how I've set up the recruiter agent inside VAPI. In the VAPI console, I've configured the assistant to use a custom LLM, not the default one that VAPI provides. And the reason for that is simple. I wanted full control. I want to keep all the core logic, all the prompting, all the flow management inside my own backend. By doing that, I get to control edge cases like end the call early if the candidate already completed the process, or if they say they cannot work 3 days a week in the office. I also considered adding logic to keep track of the interview duration so the agent could wrap things up naturally after a set time. Stuff like that would have been a lot harder if I hard-coded everything inside VAPI itself. Now, to be fair, VAPI does support internal tools and logic, and I might explore that later for better performance or to reduce costs. But for now, pushing all that logic to the app works really well and keeps things flexible. Since we use custom URL for LLM interaction for the actual conversation, VAPI does not generate the response itself. Instead, it sends each utterance from the candidate to a custom LLM URL, which in our case is a fast API endpoint that runs the interview agent. VAPI posts the candidate's voice transcription to that URL and expects a response back. Basically, the next thing the AI should say. If you're running the code locally, you would have to provide the ngrok URL, and the endpoint is /interviews/chat/completions. Once the application is publicly hosted, for example in render, we'll use the URL for render here. And here's the interesting bit. We set this URL dynamically from our Python application when we initiate the call, depending on the environment. So we can point to local dev, staging, and production as needed from properties defined in the .env file. On the voice tab, I've selected 11 Labs as the provider, and I'm using the voice call Christopher, powered by 11 Labs Turbo V2_5 model. And I've got to say, 11 Lab voices sound incredibly natural, way more human like than the default VAPI LLM voices, which can sometimes get a little robotic. Especially on longer sentences, they start dragging words oddly, which breaks immersion. With 11 Labs, the tone and cadence feel more polished and professional, perfect for technical interview. Now let's talk about one of the most important things in AI voice user experience. AI knowing when to start speaking. In VAPI, this is controlled by the start speaking plan. We set the wait time to just under a second, around zero point 0.7 seconds. So there is a natural pause before the AI starts responding. For endpointing, we are using LiveKit, which helps detect pauses more intelligently. And for the actual wait function, VAPI uses a more advanced algorithm to figure out when the user is done speaking, not just silence. This is super important during interviews. Candidates might pause to think, stumble, hesitate. It happens. You want the AI to wait, but not wait forever. This configuration gets that balance right. On the flip side, we also configure when the AI should stop talking if the candidates start speaking. This avoids those awkward moments where both sides are talking over each other. The stop speaking plan is turned with settings like word count, time based cutoff, and back off periods. So if the candidate jumps in mid sentence, the AI politely backs off without finishing its thought. It makes the interaction feel more natural. We've also added safeguards to avoid long silences or calls that drag on forever. If the candidate drops off or things go off the rails, we use silence and duration timeouts to end the call gracefully. That way, we don't waste tokens and compute. Everything about this setup is built for control, quality, and a smooth candidate experience. The voice feels natural. Responses from the LLM are timely. Candidates aren't interrupted or rushed, and the system does not hang on awkward silences. And because we are using our own custom LLM endpoint, we can tweak logic, prompts, or even routing based on real time data. Combine that with the high quality 11 Labs voice, and it really does feel like capable recruiter on the other end of the line. All right. Now let's talk about how the actual interview gets triggered and handled using VAPI. This is where everything finally comes together. Calendly, APScheduler, the AI agents, Superbase, and VAPI itself. It's the orchestration layer that makes the recruiter agent feels real. So it all starts when APScheduler hits the scheduled interview time. At that moment, it calls a function called trigger_interview with the candidate ID. This function is pretty simple but smart. It checks whether we are already inside an async event loop. If we are, it creates the interview coroutine using create task. If not, it spins up a fresh event loop with async.io.run and kicks off the interview. Either way, the goal is the same. Launch run_interview, and that's where the real show begins. Inside run_interview, we first fetch the candidate's details from Superbase and grab their first name to make the greeting more personal. If they've uploaded a resume, we run the resume agent and store the output. So the interview agent has richer context to work with. Next, we fire off the voice call. We use start_VAPI_call and pass in the candidate ID, their phone number, and a warm greeting. Something like, "Hello, am I speaking with John?" That message is what VAPI will read out aloud when the candidate picks up. Once the call is initiated, we store all the metadata into our session store. That includes everything, the candidate profile, LLM usage to compute cost for each agent, control URLs for the VAPI call, and a place to track the conversation history. All that we need during the lifespan of the call is tracked in the session state from beginning to end. Now let's look at how the voice call actually works. Inside start VAPI call, we send a post request to the VAPI's call endpoint. We tell it which Twilio number to use, which assistant to activate, what the greeting should be, and where to send two kinds of events. One for model responses, one for lifecycle events like call started or call ended. The model.url field points to our chat completions endpoint. This is where VAPI sends each candidate utterance expecting a reply. The server.url is where VAPI notifies us when the call begins or ends, so we can track everything in real time. Now let's talk about the chat completions endpoint. This is the brain of the conversation. Every time the candidate says something, VAPI posts it here. The handler VAPI chat completions look up the session using the call ID. If the session does not exist, we attempt to recreate it by calling get VAPI call. Once we have the session, we form the prompt for the interview agent. If it is the first turn, we prepend the candidate profile to give it some initial context. Then we call the interview agent and wait for its reply. When we get the response back, we run it through parse agent output. This function is critical. It does more than just parse the LLM output. It also detects edge cases and flags that might require ending the call. Things like the candidate already being interviewed, in-office requirements being a blocker, or the candidate directly asking to end the call. If any of those show up, we override the agent's reply with a polite message and set a should end flag to true. Now, if that should end flag is set and we have not already ended the call, we kick off the post interview task in the background. Post interview task function does all the cleanup. It waits for a short buffer, about 30 seconds, then ends the call, builds the full transcript, updates the candidate record in Superbase, runs the evaluation agent, and even computes how much the entire interaction cost us in LLM usage. We run compute LLM cost for all three agents, resume, interview, evaluation agents, and store the total cost back in the database. Let's take a moment to break down how we calculate the cost of LLM usage for each interview. Because let's face it, LLM calls aren't free. Every token you send and receive costs money. So we needed a way to track usage precisely and compute what each interview actually cost us. Here is how it works. Usage. We import the usage class from Pydantic AI usage, and it's used to track LLM usage cost. For every agent, resume, interview, and evaluation, we create a separate usage instance to track the tokens consumed by that specific agent. So for example, when we run the resume agent, it looks like this, and we pass the usage object in the run method of the agent. The agent takes the usage object and fills it in under the hood. It tracks how many prompt tokens, how many completion tokens were used in that specific run. And we repeat that for all three agents. The usage objects are tracked inside our session state. We store one usage object per agent. After the interview wraps up, we pass those usage objects into a helper function called compute LLM cost. This function calls calculate Pydantic cost under the hood using tokenomics to fetch the pricing for each model. You pass the model name like GPT-4o or GPT-4o mini along with the usage object, and the function looks at the tracked tokens and return the actual dollar amount. Here's what it returns. An LLM object with three fields: prompt cost, completion cost, total cost. So now we know down to the cent how much each agent contributed to the overall LLM spend. Then we wrap it all up in an agent LLM cost object that holds cost for each individual agent. And finally, we call total LLM cost method to sum it all up. That total is saved into the candidate's record in Superbase. The end result? Every interview now has a detailed breakdown of how much it costs across resume parsing, the voice interview, and evaluation. If costs spike or we switch models, we know exactly where the extra tokens are going. It's all traceable, it's all auditable, and it makes scaling a lot less scary. Now that we have got our agents built, Calendly hooked up, and APScheduler ready to auto-trigger interviews, it's time to take the app from local dev to a real production environment. We need it running 24/7, reliably, securely, and with solid observability. And for that, we are using Render. Why Render? Because for small production apps like this, it is the sweet spot. Developer-friendly, GitHub integrated, and includes all the basics like logs, metrics, environment variables, and health checks. Let's walk through the setup. We deploy straight from GitHub using this repo, recruiter-agent. Render automatically connects directly to the repo, and we have enabled auto deploys. So whenever we merge the code to the main branch, we deploy the latest code to production. Our app is named Recruiter-Agent, running in the Oregon region and using a starter instance that is zero point 0.5 CPU and 512 MB RAM. Honestly, that's plenty for light usage, and we can scale up easily if needed. Under the hood, Render runs our fast API app using UVCon. We bind to 0000 and use Render's port environment variable, so routing works correctly. All our secrets, OpenAPI keys, Supabase config, assistant models, company details are managed via environment variables. We load them into Render using the web UI. Super straightforward and way safer than hard coding anything. And to make sure Render knows the app is healthy, we configured a custom health check endpoint at /interview/healthz. This endpoint gets pinged periodically, and if it ever fails, Render will automatically restart the service. Debugging and monitoring are painless too. The logs tab shows every incoming request, every print, every exception, plus all the health check pings. And if something does go wrong during a live call, you can tail logs in real time. We also get CPU memory usage metrics. Right now, usage is super light, so our starter instance is holding up just fine. That's deployment. Clean, stable, and production ready. Let's talk about money. Because now that we have built a fully automated, voice-driven recruiter agent, we got to ask, what does it actually cost to run? There are 5 main contributors to the bill. First up, LLM usage. Every time the resume agent, interview agent, or evaluation agent runs, we are using tokens, and tokens cost money. We already saw in code how we compute the cost for LLM usage. We compute the cost for resume agent, interview agent, and evaluation agent separately per call, and we persist so we can review and audit the LLM usage. Second, VAPI. This powers the voice interaction, handling the call, speech to text, and text to speech. Pricing here is based on call duration and how much text is processed through STT and TTS. We are not calculating this directly in our app yet, but VAPI dashboard gives a clear view of usage and cost. You can check the call cost for each individual call by going into the call from the call log and then checking the call cost section. If we want, we can bring the cost details from VAPI systematically with code. Third is Twilio. We use Twilio to rent a phone number and handle outbound voice calls. To rent a phone number is $2 and change per month. Then you pay phone charges per call based on the duration of the call, which we can see from Twilio dashboard. And fourth is Calendly. The free plan only supports one event type and does not include webhook access. So we are using the professional plan at around $12 per seat a month. That gives us access to webhooks, custom event types, and API scheduling. And fifth and final cost component is Render. We are on the starter instance, which costs $7 a month. That gives us persistent backend, deploys from GitHub, logs metrics, and automatic restarts if something crashes. And that covers the full stack: voice calls, AI logic, scheduling, backend hosting, everything. We have built-in observability from day one. We know the cost for every interview, and we can track it per agent. So whether you're running 10 interviews a week or 1,000, you always know where your money is going and how to optimize as you grow. All right, it's now time. Let's run a full end-to-end demo of the Recruiter AI voice assistant. We're going to do 2 back-to-back runs. First, a normal interview where the candidate answers positively and will let the interview complete. Second, a gatekeeper scenario where the candidate cannot work from office and will watch the agent confirm that and end the call cleanly. All right, so here's our Calendly link for the interview. So we're going to schedule the interview from here. But before we schedule the interview, let's make sure that our agent is actually running fine. So I'm here in Render looking at the logs for the agent, and I see 200 okay, so which means our agent is healthy. Now let's go to Calendly, right? I'm just doing a quick refresh. I'm recording this on a Saturday, August 23rd. The time is now 1:44. So I'm going to pick 1:55 p.m. as my scheduled interview time. So I'm giving my name and my personal phone number, and then I click Schedule Event. So now what should happen is our recruiter voice agent is registered to Calendly's webhook. So whenever there is a meeting scheduled, that webhook should receive an event, and our recruiter voice agent should capture that and record that interview in Superbase. So let's go back and check the logs. So here you can see there is an incoming Calendly event type, that is event created. And we have the interview scheduled here, the name, the email, and the phone number, and also the interview schedule time. So the interview is scheduled for 1:55. This time is in UTC. So in about 10 minutes, I should receive a phone call from our voice agent. So here's the game plan. When I receive the call, I'm going to pick up. I'm going to answer the intro questions, and I'm going to answer a couple of interview questions, and then I will hang up the call. Then we'll come back, look at the logs, and make sure we see everything we are supposed to see. All right. Now we'll wait for the call. I'm tailing the logs live right now. It's 1:54. We should get a call in less than a minute. There it is. As soon as we hit 1:55, the interview is actually triggered, and I'm receiving a call right now. So I'm going to answer it. Yes, this is Jerry.
Hi, Jerry. It's great to meet you. Do we have about 30 minutes to chat today?
Yeah, absolutely.
Thanks for confirming, Jerry. I'm Tom Lanigan, a senior software engineer with Big O1. I'm here to conduct your technical screen for a position at AI in Real World. Are you ready to get started?
Yeah, absolutely. Yes.
Great. Just to give you a brief overview, AI in Real World is a global management consulting firm that helps Fortune 500 companies on strategy, digital transformation, and innovation. Now, let's discuss the role you're interviewing for. It's a senior software engineer position focused on .NET, C#, SQL, and Azure. Does that sound good to you?
Yeah, absolutely.
Thanks for confirming, Jerry. Now, I have a couple of gatekeeper questions to start with. First, have you already interviewed with AI in Real World recently within the last year?
No, I have not.
Thanks for that clarification, Jerry. Now, for the second question, this role requires being in the Gurgaon office for 3 days a week. Will that work for you?
Yes, absolutely. It does.
Great. I appreciate your confirmation, Jerry. Now, let's dive into your experience. Can you describe your current project and role?
Sure. I'm currently working as a backend engineer on a financial services platform built with .NET Core and C#. My role involves designing APIs, optimizing SQL Server queries, and deploying services to Azure using Azure App Services and Azure Functions.
Thanks for elaborating on your role, Jerry. It sounds like you have a lot of valuable experience there. Can you walk me through the system architecture you worked on for this platform?
Sure. We followed a microservices architecture hosted in Azure. Each service is built with .NET Core, communicates via REST and Azure Service Bus, and uses SQL Server and in some cases Cosmos DB, depending on the use case.
Great to hear about the microservices architecture. Why did you choose those particular technologies for the system?
One challenge was managing.
It seems like you were about to explain a challenge. Please continue with that.
Sure. So one of the challenges was managing distributed transactions across microservices. We had to use eventual consistency patterns and spend time fine-tuning performance, especially with large-scale SQL queries under load.
Thanks for providing that context, Jerry. It sounds like performance optimization was key for you. Now, could you explain how you use dependency injection in .NET Core?
Sure. In .NET Core, services are registered in the startup.cs using configure services, where I add dependencies with add singleton, add scoped, or add transient. Then I inject them via constructors and controllers or other services promoting loose coupling and easier testing.
Thank you for that detailed explanation, Jerry. It sounds like you have a solid grasp of dependency injection and its advantages. Now, could you explain the difference between value type and reference type in .NET?
Now I answered few questions and I ended the call, and I think that's good enough. We saw as soon as the time hits, we got the call, and the interviewer was going over, the set of questions he was supposed to ask. And what we want to see now is in the logs, we want to see if the resume agent kicked in and how the interview agent kicked in and how the evaluation agent kicked in. So let's go ahead and look at the logs. So the very first thing, as soon as the time hits 155, that is 1855 UTC, the trigger interview was called, and we see the logs moving. We are also seeing a VAPI call was initiated to the phone number, and the VAPI call was started successfully. We also see that. And the trigger interview function is actually called. We can also see here, we don't have a resume for this candidate in the database. So the resume wasn't available. If the resume was available, we would have seen a resume agent run as well. But you can see the resume was looked for and it wasn't available. So it went ahead with the interview call. So now we can see the interviewer introducing himself, and it's asking if we have time to chat today. The next set of questions I want to focus on is the gatekeeper questions. So the first gatekeeper question is, have the candidate interviewed for this position before? And you can see the turn outcome reasoning here, right? So the candidate is engaged and affirming, allowing us to move forward with gatekeeper questions. So this is what the AI is thinking, and it is presenting the first gatekeeper question, for which I answered, I have not interviewed before for this particular position. So the interview moved on to the second gatekeeper question. You can see the turn outcome reasoning here. The candidate has answered the first gatekeeper question, allowing us to proceed with the second one. So this time, it is asking if I'm okay to work in the Gurgaon office for 3 days a week, and if that works for me. And here I'm answering yes. So that's perfectly works for me. So it moves on with the actual interview, right? So had I answered no for the gatekeeper question, the interview would have stopped, but in this case, it moved forward. So it's now asking about my most recent project and my role, and it's also asking about the architecture. So here, something funny happened, right? So I talked about the architecture as, we had designed a microservices architecture, and it asked, and why did I chose those technologies in the first place? But what I did was I started following the script. I started giving the challenges I saw with the architecture. So this was a question. The follow-up question wasn't something that we prompted the interview agent, but it correctly asked about more details on the architecture, right? So I paused mid-interview. As soon as I said the challenges with the architecture, I paused. But the interview agent came back, rescuing me actually, suggesting that I talk about challenges, right? So this I didn't plan for it, but it worked out perfectly in the interview. So even though the candidate was stuck answering a different question, the interview agent jumped in and he was able to, continue the conversation, which was really nice. So I answered few technical questions and then I hung up on the call. So let's see how that was handled. And even though the candidate ended the call, our evaluation agent promptly started, and it basically recorded the evaluation in the database. And we have the evaluation results with the scorecard and with the summary as we expect to see. Now let's do a second run. In this run, again, I'm going to schedule an interview. And when the time hits, we will receive a call. But this time around, I'm going to say no to the work from office requirement. And let's see what happens when I say no to the work from office requirement. Let's now go back to Calendly and schedule an interview. So I'm going to pick 23rd, that is Saturday, and I'm going to pick 2:25 p.m. Hit next. So we'll come back at 2:25 when we receive the call. And this time, I'm going to say no to the second gatekeeper question, that is the work from office requirement. And we'll see how our interview agent handles that. All right. The call will initiate in less than a minute as soon as it hits 2:25. And there you go. We're at 2:25 and an interview is triggered. And I'm getting a call.
Jerry?
Yeah, this is Jerry.
Hi, Jerry. Great to meet you. Do you have about 30 minutes to chat today?
Yeah, absolutely.
Thanks for confirming, Jerry. I'm Tom Lanigan from Big O1, and I'll be conducting this technical screen for the senior software engineer position at AI in Real World. Are you ready to get started?
Yes, I am.
Great. Just to give you a brief overview, AI in Real World is a global management consulting firm that advises Fortune 500 companies on strategy, digital transformation, and innovation. Let's dive into the role a bit more. This position focuses on developing software solutions using .NET, C#, SQL, and Azure, and it involves working mainly on site in Gurgaon for 3 days a week. Does that sound good so far?
Sorry, I don't think I can be in the office for 3 days a week.
I see. Thank you for letting me know, Jerry. Just to confirm, are you saying that working in the Gurgaon office for 3 days a week will not be possible for you?
Yeah, that is correct. I prefer working from home.
Thanks for being upfront. Client has a strict 3-day in-office policy, so this role wouldn't be a fit. I'll wrap up our call now and keep you in mind for other opportunity. Take care.
All right. Now that the call is ended, let's review the logs. The very first thing in our log, as soon as the time hits 2:25, that is 19:25 UTC, the interview kicked off. Again, the resume wasn't available for this specific candidate. So it went ahead with starting the call with the given phone number. And then right away after the introduction, the interviewer said, while explaining the job description, he also said that there is an on-site requirement where we have to be on site for 3 days a week. Does it sound good so far? So for which I answered, I cannot be in the office for 3 days a week. So you can see the next question is the interviewer wants to double confirm that, I in fact cannot work in the office for 3 days a week. You can see the turn reasoning here. The agent is seeking clarification on the candidate's ability to meet the role's location requirement before proceeding further. The interviewer asks the question again just to confirm, are you saying that working in the Gurgaon office for 3 days a week will not be possible for you? For which I answered, yes, that is correct. I prefer working from home. Now look at the turn outcome here. The turn outcome is gatekeeper failure in office not possible. And that is the turn outcome reasoning. So this is agents, this is the AI thinking. The candidate has confirmed that they cannot meet the role's on-site requirement. I am indicating a mismatch with the position. The interviewer responded, thanks for being upfront. Client has a strict 3-day in-office policy. So this role wouldn't be a fit. And after the last sentence, we are initiating the end of the call, and we are adding a 30-second buffer so the call doesn't end abruptly on the caller. And, as coded, the call was ended successfully, right? And you can also see here the evaluation agent kicked off. And you can see there's nothing in the transcript for the evaluation agent to actually evaluate the candidate. So you see a lot of one in the scorecard, and finally, there is no and the summary also suggests that the candidate basically said no to a 3-day work from home policy, so it's not a fit, and our evaluation agent is not recommending the candidate. And finally, everything is recorded in the database along with the cost. So the total interview cost is about 1 cent. It's about 1 cent. So it's nothing from the LLM usage standpoint. And of course, there's the VAPI cost, and then there's the Twilio cost to consider. But just from the LLM usage standpoint, it's 1.2 cents, which is nothing. Cool. I think everything worked, as we designed it. So this is a good, demo run for the agent. All right. We have reached the end of the Recruiter AI Voice Assistant video series. We have taken this voice assistant from an architecture diagram to a fully automated AI-driven interview agent. In this series, we designed the architecture and chose Pydantic AI for clean orchestration. We built the resume, interview, and evaluation agents with tighter prompts and business rules. We wired Calendly to APScheduler for hands-off scheduling. We added real-time voice with VAPI and Twilio. Logged turn-level reasoning, stored results in Superbase, deployed to render and track costs, so this is practical at scale. We also proved the agent working with 2 live demos, one with a normal flow and another flow where we say no to gatekeeper question that ended the interview gracefully. If you followed along, you now have everything you need to spin up a production-ready recruiter assistant. If you're new here and this is your first stop in the series, I recommend starting from the beginning. We built this step by step. And if you're a business owner and want something like this or a fully custom AI assistant, there is a link in the description to schedule a free consultation call with us. Now for the fun part. The next series is called Freelingo, a free AI-powered language learning app inspired by Duolingo. Here's what we'll build together. A multi-agent, agentic workflow with a full user interface that can be used by language learners for learning a language with live dialogue sessions, planning, and feedback by AI agents. We will be developing both UI and agent backend with Cursor, the vibe coding IDE. So you get to see how I use vibe coding IDEs for my development. If that sounds interesting, subscribe and hit the notification bell. Freelingo series kicks off next. It's practical, it's hands-on, and yes, it's free. Thanks for watching. I'm Jerry. This is AI in Real World, and see you in the next video.